All right, this is the Chapter 2 review packet. I'm just going to run through, try to do the problems real quick for you, so if you get on here and look at this video, you could get some of the answers if you have trouble with it. If and then statements are also called C, conditional statements. Also called conditional statements. Number 2, which statement follows from statements 1 by the law of syllogism? It says if an object is square, then it is a rhombus. So square goes to rhombus. Then it says if an object is a rhombus, then it is equilateral. So from that we can say a square tells us that it's equilateral. Which is, if an object is square, then it's equilateral, that's B. 3, which statement shows the symmetric property of equality? Remember, symmetric's just where it's got two things on the equal sign and it flips them around. So as I'm looking at this, that looks like B is the symmetric property. Number 4 says angle 1 and angle 2 form a linear pair. If they're a linear pair, then we know that they are supplementary. So if these angles are supplementary, and they tell us angle 2 is 104 degrees, so all we have to do is take 180 minus 104, you get 76 degrees. So angle 1 has to be 76 degrees, which is letter C. Number 5, name the property that justifies the statement. If 2 plus x equals 12, then we know x equals 10. Well, all they did there was they subtracted 2 on both sides. So it's the subtraction property of equality, which is letter C. Number 6, freshman class of 63 students conducted a survey to compare how many students took Spanish as opposed to French as a foreign language. The results are shown in the Venn diagram. How many students studied Spanish or French? So Spanish or French. Key word there is or. Well, so we're looking at our Venn diagram. It looks something like this. You got 1 there, 40 here, 15 there. To get this answer then, let's see, this is Spanish, this is French. To get the answer, since it says or, these people in here count, these people over here count because they take one or the other, and this person in here, even though they take both, counts. So looks like 56, which is letter B. Number 7, in the figure, points A, B, and C lie in plane Z. Which of the following postulates can be used to show that A, B, and C are coplanar? Coplanar again. Coplanar means in the same plane. It says through any 2 points there's exactly one line. Well, that's telling us that 2 points would be collinear. Through any 3 points not on the same line, so non-collinear to each other. There's exactly one plane. 2 lines intersect, they intersect at a point. And D is if 2 points intersect, or if 2 planes intersect, then an intersection is a line. Well, the one that works here is B. Number 8, which postulate states that if B is between A and C. So if B is between A and C, then AB plus BC has to equal AC. Well, that's a segment addition postulate, which is letter B. Number 9. Says we're given x is a real number. Real numbers are all the numbers that you know up to this point in your mathematical career, and the conjecture is that negative x will always be less than 0, and they say determine whether it's true or false, and then if it's give a counterexample if it's false. So if x is a real number, it could be anything that you know right now. So 1, 2, 3, 4, 0, -1, -2, -3, -4. Could be 1/2, 1/5, 0.275. Any of those numbers work because those are all real numbers. So if we pick one, maybe we pick something like 2. Well, if we stick 2 in there for x, then that would be less than 0, but that, just because it works for that one doesn't mean it works for everything. And the counterexample that we could come up with to show that this is false is if x was a negative number. So if x was -12, x equaled -12, we stick that in there and we get the opposite of -12 is less than 0. Well, the opposite of -12 is +12, and that's not less than 0. So it's false. An example would be something like x could equal -12. You didn't have to pick -12, it just happened to be what I picked. Number 10, 7x minus 10 equals 25. That's what we're given, and we're deciding on the conjecture that x equals 5, whether that's true or false. Well, if we plug 5 in there, we get 7 times 5 minus 10 equals 25. That's 35 minus 10 equals 25, and 25 equals 25. If you remember from algebra, if that number works, so if x equals 5 in a linear equation, if you stick in one, there's only one possible answer for x when you stick it in there. So x has to equal 5, so this one comes out to be true. Number 11 says write the conditional statement if and then form. 2 complementary angles must add up to be 90 degrees. Well, an if and then form means I want to start off with if. So if 2 angles are complementary, then they add up to 90 degrees. That's an if and then form. Number 12. Say write the converse, inverse, contrapositive of the statement. Tell whether each is true or false. The original statement is if 2 angles are vertical, then they are congruent. The converse, remember, switches the hypothesis and the conclusion. This is your hypothesis. This is your conclusion. So converse is going to say if 2 angles are congruent, then they are vertical. And just because 2 angles are congruent doesn't mean that they have to be vertical, so this one is false. The inverse negates leaves it in the same order but negates it, so it's gonna say if two angles are not vertical, then they, and messed up, are not congruent. So if you got two angles and they're not vertical to each other, that doesn't necessarily mean that they're not still congruent, because it could be any two angles. So that one is false. Contrapositive. The contrapositive switches and negates it. So it would say if two angles are not congruent, then they are not vertical. If you got two angles and you know that they're not congruent to each other, then that tells you that they can't be vertical. So this one is true. So again, on this, it's a pretty important one for the test. You're going to get a couple of points each for these, point each for telling whether it's true or false. Number 13, if possible, write a conclusion. If no conclusion is possible, write no conclusion. 13, it says perpendicular lines form right angles, so perpendicular lines, and I'm going to shorten this up with our implies there. Perpendicular lines implies right angles. Lines A and B are perpendicular, so A is perpendicular to B. Remember, it's got to go in the right order. Well, this has perpendicular lines, and the first thing they tell us in the second one is that it's perpendicular lines. So then the conclusion that we can come up with is that A and lines A and B form right angles. That would be our conclusion. Number 14 says all pugs are dogs, so pug, being a pug, tells us that it's a dog. And then it says Fred is a dog. Well, this is what it's telling us is the second part. We can't start at the end. It would have had to start with pug. So this one, we just write no conclusion. We can't decide whether Fred's a pug or not because we don't have enough information. Number 15, to show a conjecture is false, how many counterexamples must you provide? Probably the easiest question on the review. To show something's false, you only need one counterexample. Number 16 says Q, and it's got this symbol, P. They tell us that Q is -6 is an integer. So we write this out. This symbol means and P is a pentagon has 5 sides. Now we go through, we decide, is 6 an integer? Yeah, so that part's true. We got and in there. Pentagon has 5 sides, that part's true. Since this part's true, that part's true, it's and. That means the whole thing is true for number 16. 17, R. It says R and not Q. See, R is translated here. Complementary angles add to 180 degrees. That symbol is and again. We want not Q this time. Q is -6 is an integer, so we want to say -6 is not an integer. This one, complementary angles add up to 180. That's false. We got and, so it really doesn't matter what the second one is, but we're going to do it anyway. -6 is not an integer. That's false also. That tells us this whole thing is false. 18 says Q, got this symbol R. Remember, the symbol is for or. So this is going to say -6 is an integer, or complementary angles add to 180 degrees. Well, 6 is an integer, so that part's true. When it says or, only one part or the other has to be true for the whole thing to be true. So even though the second part's false, the whole statement is true. Number 19. Give us a picture. It looks like this. W, Z, Y, X. And they tell us that angle X, Y, Z, that's this whole angle, is 122 degrees. And the angle XYW, that's this angle, is 80 degrees. And they want us to find this angle over here. We're using the angle addition postulate. We know that this angle plus this angle should add up to be the whole thing. So we're just sort of using it backwards. 122 minus 80, that's 2, borrow there, 42. So that remaining angle has to be 42 degrees. Number 20. We know angle 1 and angle 2 are a linear pair. Angle 1 is 65 degrees, so to find angle 2, we just subtract from 180. Get 115 degrees. That's our answer. Problem number 21, one of the 2-column proofs. They give us a diagram that looks like this. Looks like a diagram we've seen before. As soon as I look at this diagram, I think of segment addition postulate, if I could draw it correctly. They tell us that segment AB is congruent to segment BC, segment AD is congruent to segment DE, and then they tell us that BC, which we've already marked, is congruent to AD. This one up here, well, this one's got 1 tick mark on it, this one's got 2 tick marks on it, so something's not right there. So what we probably need to do is put 2 tick marks on this. Well, if we put 2 tick marks on that, we still know it was congruent to this one, so this one has to have 2 tick marks on it, and then that tells us that all 4 of these are congruent. It also tells us that B and D are midpoints of each of the segments. And we're trying to prove that segment DE, which is right here, is congruent to segment AB, which is right here. Well, we've sort of proved that using substitution in there, transitive property, depending on which one we're able to use. So we should be able to go through and write this 2-column proof. Got our statements. First statement is, and again, they put both of these in one step, and that's fine. I'm going to do the same thing on this one so I don't mess anybody up. Segment AB is congruent to segment BC, and segment BC is congruent to segment AD, and And we knew that because it was given to us. Now we look right here, and that looks like we're gonna be able to use the transitive property. So the transitive property tells us if AB's congruent to BC and BC's congruent to AD, then it tells us that AB has to be congruent to AD. That's what the next one says. We can say that because of the transitive property. Then they say that AD is congruent to segment AD is congruent to segment DE. Segment symbol up here. So they're saying that segment AD is congruent to segment DE. And that was, if we went back, that was one of our given. This is part of the reason I don't want all the given up there, because that sort of confused me for a second. So we're actually using the third given statement way down here, down lower in the proof. And number 4, well, if we look right back here again, segment AB is congruent to segment AD, segment AD is congruent to segment DE, well then that tells us that segment AB is congruent to segment DE. And we know that because we use the transitive property again. Now, we were trying to prove that segment DE was congruent to segment AB, which is real close to that, but it's not quite right. What we need to do is turn it around. Well, the property that we have that allows us to turn it around like that is just the symmetric property. So even going back to what I said originally about using segment addition postulate, we didn't even need it on this one. It was unnecessary. So I was wrong when I assumed that at the beginning. Number 22. Says we are given that 4 is 3x plus 4 plus 6 equals 70. Can't quit writing out there. And we're trying to prove that x equals 4. Got our statements and our reasons, no picture on this one, so we're just going to start off by doing the math. Alright, we knew all that because they told it to us, it was given to us. Step 2, first thing I want to do here is get rid of the parentheses. That gives me 12x plus 16 plus 6 equals 70. Distribute out the 4 to each of those. And I used distributive property there. Next thing I'm going to do is collect those like terms there. So I got 12x plus 22 equals 70. And all I did there was addition, or probably better to write substitution. Use substitution, you replace the 16 and the 6 with 22 because you knew it was the same thing. Then next, end up with 12x equals 48. The way I got that is by getting rid of that 22 there, and I did that with subtraction property of equality. Next step, I end up with x equals 4. And what I did there was I used the division property of equality. So 5 steps. That's what we were trying to prove, so we're finished. And that's the review packet. Hopefully if you watch this, help you out some, help prepare you for the test next class.